Okay, so this is second video of worksheet 5.1. I'm going through section B now. Okay, so in section B, the first question, question 10, you have a plumber and a spanner, and you use a spanner to actually turn this nut in a clockwise direction. Alright? So which section requires smallest force? Smaller force means that it must be furthest away so that I can have a smaller force. Okay, so in this case it will be C, because C is furthest away from the nut. Now, a lot of you miss out this question, so please take note. Okay, draw an arrow to show the direction of the force. Now, it is very easy to draw an arrow that is curved because you think that there will be a clockwise movement here. But that is not how a force usually is. A force usually is a straight one, so you need to draw it straight. Okay? And then usually when you draw an arrow with a force, you should label it. So this is F. This is the force acting this way. Okay? Question 11. So you have a uniform beam pivoted at the middle. Okay, a mass of 2 kg suspended at 50 cm to the right. So the 50 cm, 2 kg. Now first one, calculate the weight of the mass. Okay, so this weight here, if you recall the formula, W equals to mg. W is your weight, m is your mass, g is your gravitational field strength. Okay, so mass is 2.0 kg. G on Earth is 10, so we just assume it's 10. And so you get 20 newtons. Alright, so here please take note, remember to write formula, you have your working, and your answer, your unit. Part B, calculate the moment of this force about the pivot. So same thing, write your formula, force times distance. Now this force, remember that weight is also a force, it's a force due to gravity. So I can use this number, 20 newtons times distance. Now if you look at the question, the distance given is in centimeters. But when we use to calculate this formula, we need to convert it into meters. So 50 cm is actually 0.5 meters. So here the answer is 110 Newton meter. Okay? Okay, last one. Okay, last second question. Calculate what direction, anti-clockwise or clockwise, is the moment in B. So here we look at this one. The force goes on this way. Okay, it's a downward force along the pivot. So if it goes this direction, it is clockwise. So for this one, it's clockwise. Okay, finally, if you look at this one, Justin wished to balance the beam. Okay, we're looking at balancing the beam. Balancing the beam means that I must have another force here, somewhere here, okay, that actually causes an anti-clockwise moment that balances out, or that's equal to this moment. So, what is the moment that's required to balance the beam? It must be the same as the clockwise moment, which is 10. So this must be the correct answer. Okay, it must be the balanced one. The direction must be the opposite direction, therefore must be anti-clockwise. Now, not all the time you have to convert to meters. So in an event you choose not to, okay, this is another way of doing it. So 20 newtons times, if you are leaving in centimeters, my answer here will be 1000. Okay, but what will be my units? My units in this case will be Newton, centimeters. So I must write this way, Newton, centimeters. So the units matter, depends on what the question asks for. Okay, so this concludes worksheet 5.1.